Cemented Vibro-Replacement Stone Column Assisted Dam Cutoff Wall Construction Technique. The dam cutoff wall serves as the core barrier for seepage control in the reservoir area. The stability of the foundation on both sides of the wall directly governs the reliability of the seepage control system. To improve the bearing capacity and integrity of the foundation adjacent to the cutoff wall, the cemented Vibro-Replacement Stone Column Reinforcement Technique is adopted. The cemented stone columns and the dam cutoff wall complement each other, forming a three-dimensional foundation reinforcement system. The installation of cemented Vibro-Replacement stone columns on both sides of the dam foundation is applicable to hydraulic engineering projects that require rapid enhancement of sliding stability, seepage control, and liquefaction mitigation. After start-up, the Vibroflot penetrates complex strata through high-frequency vibration and high penetration capability and forms a borehole under the action of high-pressure water jetting. Upon reaching the design depth, crushed stone aggregate is fed through the feeding system while cement slurry is injected via the Vibroflot. The Vibroflot performs continuous vibratory compaction to achieve tight bonding between the cemented stone columns and the intercolumnar soil. This rapidly increases the effective stress and shear strength of the intercolumnar soil and raises the factor of safety against sliding for the bank slopes. The cutoff wall has a width of 2 meters, with 3 to 5 rows of cemented Vibro-Replacement stone columns uniformly arranged on each side. The columns have a diameter of 1.1 to 1.3 meters, a center-to-center spacing of 2.5 to 4 meters, and a depth of 30 to 100 meters. They can be arranged in triangular or rectangular grid patterns to selectively reinforce weak zones and enhance the lateral deformation resistance of the dam foundation. The two structures have complementary functions, are arranged in distinct zones, and work in synergy to ensure the dam's seepage stability, foundation deformation stability, and seismic stability, forming a lateral reinforcement barrier. Upon full completion, the cemented stone columns extend deep into the compaction stratum and are closely integrated with the cut-off wall, establishing a dual protection system of cut-off wall plus cemented stone columns. The foundation is reinforced from both sides to consolidate the dam's foundation for seepage control performance. Cemented Vibro-Replacement stone columns serve two core functions. First, they improve foundation bearing capacity, disperse overlying loads, prevent foundation settlement and deformation, and maintain the stability of the cut-off wall. Second, they provide auxiliary seepage control. Densely arranged columns block bypass seepage, reduce seepage pressure, and deliver all-round seepage control and reinforcement effects. The semi-rigid skeleton formed by the cemented stone columns provides lateral restraint and sliding resistance, cutting off shallow sliding surfaces. It increases the stability factor of bank slopes and prevents initial instability of both abutments from triggering sliding of the entire dam, foundation, and dam body. Cemented Vibro-Replacement stone columns work in synergy with the cut-off wall to both reinforce the foundation and provide auxiliary seepage control. They effectively improve the stability and durability of the dam seepage control system and ensure the safety of the reservoir area.